Good afternoon and welcome to everyone joining us today for our Sussex Maths Hub webinar, A Focus on Fluency. We're thrilled to have Clare, Christie, SLE, Marketing Specialist and Maths Hub Lead from Boolean Maths Hub down in Bristol. She's a regular collaborator on the NCTM resources we all depend upon, such as the PD Find, the Ready to Arrest material, also co-developer of Number Sense, a fantastic website full of great freebies that we urge you to go and explore. So we're thrilled to have you.
Oh, it's nice to be here. Really nice to be here. So yes, Jenny said, look, let's do something about fluency. And it was a great opportunity to bring together various kind of things that had been going through my mind, various different strands. So I've really enjoyed putting this together. And so the three aims of the national curriculum, lots of you will kind of have that kind of fluency, reasoning, problem solving trio that kind of trip off your tongue to a greater or lesser extent. Fluency, if we look at the actual definition in the national curriculum, it's actually so much broader than I think you'd anticipate. So just have a read of that. So that's definitely a wider definition of fluency than I suspect most of us would give if we were asked just to write down what the, and that's directly from the national curriculum. That's the aim of how that aim is worded. So a few things that stood out for me there. And underneath that in the national curriculum, there's then a little bit more that uses the word fluently again. So that got me thinking about this idea of not just kind of fluency in facts and stuff, but actually fluency in that kind of mathematical language and the wider sense of the word kind of language. And so we're going to talk about different aspects. I'm going to pick up on that reference to representation, and that it's talked about fluency in those representations of mathematical ideas. Fluency in language, I mean, obviously fluency is something we very much associate with languages and language in general, but in mathematical terms. Fluency in counting, and then fluency in number facts. So I'm going to look at those four aspects of fluency. And I'm very much going to kind of refer out to the non-statutory guidance that I was really lucky to work on last year. It was a very, very privileged professional development experience. And I think that picks up in all of those. And yeah, that is a really kind of timely document given what's happened over the last 12 months. Yeah, so fluency in representation and structure, just a reminder of what it says in the national curriculum. And so what does that mean? What is it to be fluent in representation? So just to have a look, this is from the non-statutory guidance. So from the introduction, have a read of that. And why is fluency and representation important? Well, this really stands out to me here. And that feels like a really important idea. Consistent use of the same representations across year groups connects prior learning to new learning. And so, yeah, we're going to have a dig into that. And I'm actually going to choose one representation to talk about to try and pull together that coherent journey. And that representation is the number line. So this is from the actual national curriculum, the statutory requirement. So if you're in year 2, you might recognise that. I'm just going to grab a couple of props. And as well as that, so that is one of 2 mentions of representing number on a number line. So that's really key. It's not saying do some calculating on a number line. It's represent numbers on things including a number line. Okay, so there's 2 statutory mentions of it, and they are both in Key Stage 1. But there's actually in total 9 mentions in the national curriculum, but 7 of them are non-statutory, about the importance of representing numbers on number lines. So have a look at those 2. So all of the non-statutory mentions of the importance of being able to represent number and place number in that linear number system, all of those in Key Stage 2 were pushed into the non-statutory guidance. And I don't know exactly why that is, but there's definitely been some of the people that were involved in writing the national curriculum who've spoken fairly publicly about kind of ministerial interference. And I think there was, my personal hypothesis is maybe there was a sense that number line was associated with very inefficient calculation and lots of jumping on, and that number lines were not good. Think about number lines for that. This is number lines as a representation of number, and that really is important. I would heavily recommend to you this brilliant talk by Ruth Trundley. If you Google like Ruth Trundley structured number lines, who works for Jurassic and down in Devon, and this piece of action research, there's a talk here and then a piece of action research. It's absolutely brilliant, and it is all about representing the linear number system. So we put a strand in the non-statutory guidance on that, so I'll just let you have a little look at that. And that runs all the way through, that children should be reasoning about the place of numbers in the linear number system. And there's a couple of things in that. So specifically reading marked number lines and also estimating a position in unmarked number lines. So I've grabbed a couple of these. I've got it the right way around. Can you see that? I've got, oh my God, I've got all sorts of reverse line. There we go. These are absolutely brilliant. So this is just like unmarked number line 0 to 1,000. Where do you think 300 goes? I'm going to go the wrong way, I think, because it's all back to front. Okay, no, I'm sorry. Actually, no, this is 0 to 10,000, this one. And then flip over, and then you've got your mark. There's such a lovely tool for helping children understand the number system. They're just double-sided and made up in different intervals. So estimating and marked number lines, and they're really different skills, those. And then also being able to place the number you're given, but also look at the number line and read the number that's placed there. So that's all explained in the non-statutory guidance. I don't think it comes across nearly clearly enough in the actual national curriculum. So what does that mean? So this is year 1, and this is an example of marked number lines, and just have a look at that and how different children in a year 1 class would be able to tell you the length of that leaf and quite how much that shows about their depth of understanding of the position of number in the linear number system. You know, there will be year 1s to count up 1, 2, 3, 4, 5, 6. There will be some that count on for 10, and there will be some that know that 15 is the midpoint and it's 1 less and it's 14. So from that very simple question, you've got a really good insight into children's understanding of the linear number system. And then this one here as well, year 1, these are 10 centimetre strips, estimate how long the pencil is. And so this is estimation. And that estimating on a blank number lines really develops children's proportional reasoning, that having a rough estimation of where, for example, 8 is in relation to 0 and 10. So that estimating goes all the way through in every year group, and is very revealing. And, you know, actually if children could do that, they've mastered, you know, that aspect of the number system. So we talked in the guidance, it talks about connecting prior learning to new learning. And one thing that's definitely exposed in our practice this year in school, we've done a lot more work on number lines as a result, and had such fascinating conversations with the year 4s. So traditionally, I guess we've done like, you know, the classic 4-digit numbers with year 4s, and, you know, put numbers on number lines, but the focus so explicitly on number lines as an aim in itself, not just as part of some numbery stuff, has really allowed us to actually make linkages back. So look at that there, and you know, the classic mistake fine, all the year 4s will know that's 25, but there will be year 4s that will tell you that's 205 and that's 2005. And so you can just straight away, that's going to tell you something about the child that can go 25, 250, 2,500 is absolutely in a different place in their understanding of the number system to the 25, 205, 2005. So one of the benefits of having a continuous representation that moves through the school. So yeah, that's how some of the guidance is phrased. And there's also an aspect of number lines divided into graphing intervals in there as well. So 2, 4, 5 and 10 parts. We felt just really strongly there was nothing on that. There's counting in 25s and the national curriculum comes way too late in over the 25 pattern in year 3, definitely. So we put these graphing intervals in, another aspect of the linear number system. And again, that representation that moves through there, that fluency in doing those things. So let's just have a look at this. If they're really fluent in that in year 3, I mean, that's a really revealing question. Okay, fill in the gaps. They're 4 equal parts. And that is, if you give that to year 3s, that reveals so much. Who just knows they're 25 and who's starting from first principles to try and work out what goes in there. You know, that 25ness and 4ness is so integral to our number system, isn't it? So that's year 3, and you'll see a very similar model for year 4 and a very similar model for year 5 with decimals. And that obviously also then links into the number line as well. So let's just have a look at year 3, thinking about being able to mark up these graphs fluently. Oh, 4 parts, it's 25. Oh, 5 parts, it's 20. Because for this and this, there will be children starting from first principles. What might it be? Might it be 10? Might it be 5s? And if they're fluent in that, 2, 4, 5, 10 parts, then we can extend that through the number system, can't we? Okay, so this is all year 3, but actually lots of year 3s, you know, would find this challenging because it's not pulled out clearly in the national curriculum. So that's why I've chosen the number line as a representation that has been missed really in the national curriculum in the way it's been pushed into the non-statutory guidance. It's all there in the new non-statutory guidance, it's all in the actual national curriculum non-statutory guidance. It says all the way through represent numbers on number lines, but in the guidance in the actual national curriculum is ignored. And then by year 6, you know, let's do that on any, okay, 4 parts is going to have some 25ness in it, isn't it? 4 parts. Okay, 5 parts is going to have some 2ness of some kind in it. 10 parts is going to have some 1ness. You know, we know that now because we've done this every year. And then, you know, this is year 6, read your scales in year 6. By year 6, okay, we've seen that number line go with us, 2, 4, 5, 10 parts. And this becomes second nature. Okay, look, 2ness, 5, that's 2ness. Okay, it's going to have some 2 parts, going to have some 5ness in. 4 parts is going to have some 25ness in. 5 parts is going to have some 2ness in, and so on. And you know, connecting other representations, of course, this one runs all the way through as well. And I'm just going to just get you to read this from the EEF report. So the only representation we've talked about so far is the number line, and we've talked about different aspects of the linear number system, marked, unmarked, 2, 4, 5, 10 parts. But actually connecting it to another representation helps develop conceptual understanding, but this balance with this at the bottom. And so I'll just give you one really specific example of how it's helped, you know, how it helped in year 4. We had children doing, you know, looking at that as 205ness in year 3 and 4. But well, what do we know? We know that 100, there we go, there's 10 tens in 100. We know that there's 10 tens in 100. So we can use that knowledge. 10 tens are equivalent to 100 to then start to bridge. Okay, come on, 10 tens are in one of those hundreds, right? Do you remember we did that with the tens frame? Do you remember that? So look, we've got an interval of 100 here. Okay, so that's 10 tens in there. And then that starts us to identify the midpoint as 5 tens and supports us to do that. So if we don't know what the midpoint of, you know, whatever it was, 200 and 300 is, then what do we know about the interval of 100? What do we know about half of 100? And the tens frame is a way to link that to that. So just a couple of representations that run all the way through the non-statutory. So just a reminder there, we need to be able to move fluently between representations of mathematical ideas. So the second area I thought is just pulling out fluency in language. I've just got a couple of examples with that. So again, this is from the non-statutory guidance. So just have a little look at that. And this phrase for me I can't remember who wrote this in last year, but capture has been so helpful for me in thinking about those rollers like mathematical generalizations. We learn, you know, we look at the tens frame, we see there's 10 tens in 100, and we see there's 10 hundreds in 1,000, and we see there's 10 tenths in 1. But that language then captures it. 10 hundreds are equivalent to 1,000. It's like, to me, that language is like, okay, that's saying what we're seeing, and then we can take away what we see, and we're left with this like verbal photograph of it. And I think that helps recall and apply knowledge. So I'm just going to suggest that to you and give you a couple of examples of how I think that you could think about that. So if you've all been involved with Maths Hub work in some way, and you will have talked about this idea of generalizations and stem sentences, I'm sure. So this is kind of a bit of how I think about it at the moment. The generalizations, 10 hundreds equivalent to 1,000. That's our photograph. That's our verbal photograph that captures that learning. And I think of that a bit like, okay, I'm a rock climber. I've got that. I've put something safely in there, and that I can hang on to that bit now. And now I can move forward from there. So let's have a look at this one. 10 tens are equivalent to 100. That is my generalization. That is my universal mathematical truth, and that's going to be really useful for me. Because then if I know that 8 add 6 is 14, and I know 8 tens and 6 tens is 14 tens, then, okay, but there will be year threes that don't know how to write that. They can say, I know 8 and 6 is 14, so 8 tens and 6 tens is 14 tens. But what's 14 tens? What does that look like written down on the page? Well, what do we know about 10 tens? 10 tens are equivalent to 100. Okay, so it's 104 more tens. And again, that's been really useful, in year 4, that 10 hundreds are equivalent to 1,000. Like, to me, the classic year 4 error is your kind of 800 add 600 is 1,014, because they can see the 1,000ness and they can see the 14ness, but they don't know how to put them together. So if we can say 800 and 600 is 1,400s, again, how do I don't know how to write 1,400s. What does that look like in digits on a page? So we have to help them get that, and that generalization is so useful there. Well, what do we know about 10 hundreds? Oh, that's 1,000. Oh, and then it's 4 more hundreds. So to me, that's an example there of that capturing being critical. If they can't just say 10 hundreds is 1,000, then it's going to be really hard for them to work out how to put 1,400s down in numerals on a page. And a classic one here, the whole is divided. Well, I can't remember how to find 3/5 of 40. Well, look, it's telling us what to do. The whole is divided, and if they've got that fluency in that, the whole is divided into 5 equal parts, and 3 of the parts is 3/5. They have just told you, okay? So that's what you've told me. The children can rattle that off because they've said that stem sentence so much. So you have just told me, year 6, what to do. You have just said the whole is divided into 5 equal parts, okay, like that, yeah. And that 3 of them is 3/5. You have literally just told me that, year 5 or year 6. So that has allowed you then to apply that to the mathematics, because then we can say it was divided into 5 equal parts. Well, that must be 8 in each part, and we want 3 of them. So, this stem sentence here kind of captures and then allows them to apply that learning in a way they would not be able to do if they were not fluent in that language, in that piece of language. So just a couple of examples there of how I kind of slightly have these two things in my mind now. But I love that idea of the generalization capturing something important and putting that in right. I know that now. No one can take that away from me now. I've got that to work forward from. So the third thing I was going to talk about was fluency and counting. And this comes through, I think, pretty clearly in the non-statutory guidance. And this was a massive miss for us in year one last year. We should have been really clear with parents at home that we would love them to be able to count backwards. So we informally assessed against the ready to progress criteria for the first 3 weeks back in September. And our percentage of year twos that could count backwards from 100 fluently, which is a year one ready to progress criterion, 30%, just over 30% of our year twos in September could count backwards from 100. That was a really big miss for us, because if you can count backwards from 100, right, you start to know some really useful stuff about the number system. If I know that it goes 80, 79, then okay, I can then say that 1 less than 80 is 79. And then I'm preparing to do, 80 minus 4. Classically, I find year twos find subtracting ones from a multiple of 10 really hard. 80 minus 4, oh, that's 86. So it's such a common answer. Like, no, it's not 86. It's really not 86. But, actually, if they can't tell you that, if they can't count backwards, 83, 82, 81, 80, then they have absolutely no chance of telling you, of moving to getting the idea that 80 minus 4 is 76. So it's so critical, that backwards fluency through the number system. And yeah, when I talk about counting, I'm going to just pick up on a couple of things that might be different aspects of counting that I think the non-statutory guidance hopefully does a good job at. So yeah, dual counting, again, some of you will have talked about that in Maths Hub work groups, but if you just look at have a look at the language box at the bottom there. So this is the next few slides I've taken from the PowerPoints that the NCETM produced over the summer, ready to progress exemplification criteria. They're really, really, really brilliantly useful, and I would really commend them to you for the return to school after lockdown. If you are thinking of kind of stripping back the curriculum and trying to put some of the ready to progress work at the heart of it, then if you haven't seen those PowerPoints, Jenny, I don't know, maybe one of you can bung a link in the chat or something. They're absolutely brilliant. So this is one. When I'm using them with the children, they come with guidance on what you could say to the children. What I do is just duplicate every slide and then get rid of the words so they're not overwhelming for the children, if that makes sense. So when I'm doing it with the children, I actually only have the images showing, but then I have that on the slide after, just a reminder of the questions, because I think there's too much, it's visual clutter for the children. So they're absolutely brilliant. They're all done for you. So yeah, let's do some dual counting. So, what's that there? 7, 8, 9, 10, 11, 12. Yeah. We can also go 7, 8, 9, 10. Actually, I realise that's now got an error at the bottom. I just put it up. So we've got 10, 1, 10, 1, 1, 10 and 2, 1, 10 and 3, 1, 10 and 4. Okay, 2 10s, 2 10s 2, 2 10s 3, 2 10s 4, 2 10s 5. And recognising that our number system, the teens numbers in particular, do not represent the structure of the number in the way they do in languages like Welsh or Chinese, which are highly regular. So 11 in Welsh is 1 10 1. So counting two ways, counting forwards, counting backwards, okay, what have we got there? 51, or 5 10s 2, 5 10s 1, 5 10s. 4 10s and 9, 4 10s and 8, 4 10s and 7, 4 10s and 6, 4 10s and 5, 4 3 2, 4 10s. Okay, what's going to come there? 4 10s? Oh, 3 10s and 9. So those are lovely. They're just brilliant. Do lots of counting. There's lots of different reps. I think there's about 4 or 5 different useful counting forward and backwards representations for year one. And this one is absolutely brilliant. Actually, that idea of ticking into the next place value column, I think it's really, I don't think we really ever show children that very much. It's that stopwatch idea, and there's something really powerful about seeing what's going to happen when they, okay, every time it gets to 9 in this column, I ping into the next column. And then what happens? I get up all the way up to 99. What's going to happen when I get to 99? Oh, you can see you very visually seeing that. I think I'm in reverse, by the way. You'll have to, I don't know. Yeah. Anyway, you'll have to figure it out. You know what I'm doing. So those are great. And the counting, you know, again, number line as well. Can they say 70 to 69? So those PowerPoints are available for every ready to progress criterion. They're brilliant. And you know, the same principle applies in year 5. This is year 5. We did decimals for all of the autumn term in year 5. And again, thinking about dual counting here was really powerful. So I'll just let you have a think about that for a second. How would you count from this number? Try and just think in your head, say of 2 different ways that you could do counting on this number line to expose structure. And one thing we did this year in year 5 that was super powerful was we didn't read out any numbers as 0.8. We read them as 8/10. So this is another like estimating thing. These were great in year 5. We did try to do all our decimals and kind of measures integrated. So again, this is that estimating element of the number facts. These are just like jumbo sticks cut into, can you see those? No, hang on, there. So they've just got 1/10 of a metre on, and we would read that with the children. They are not allowed to read that as 0.1 metre. They have to read that as 1/10 of a metre. Honestly, if there's one thing you want to do to get children understanding decimals, just do that. Get them to, and that's fluency, isn't it? What is that number? Oh, that's 1/10 of a metre. You know, the number that we write 0.4. If they're fluently reading the number that we write 0.4 as 4/10 of a metre, I mean, oh, well then they're just saying what it means every time they read it, because 0.4 has no structure. So these are great. Out in the playground, we had all the PE equipment out, and you know, something that is this long, you know, okay, what is it to the nearest metre? I'm sorry, to the nearest 1/10 of a metre. And then when we'd met hundredths, then we could start estimating it to, okay, we think that's 1/10 and about 400ths of a metre, and writing those. So the practical, out in the playground, year 5s were all out there. They all had their little pack of 10/10 of a metre measuring sticks. Off you go. So yeah, reading this as, you know, counting 8/10, 9/10, 1 and 1/10, or 8/10, 9/10, 10/10, 11/10, and so on. So fluency in counting, really, you know, if they're reading that as, you know, 7 and 1/10 and so on, that's really powerful for them. And then, so we talked about dual counting, and the other aspect of fluent counting comes back to something you'll recognise I just touched on earlier. And to me, that like 25 pattern, like that again is one I really try and push them to be fluent on. I want to be able to walk up to any child in Key Stage 2 and say 25, 50, and then say back to me 75, 100. Because if they're fluent in that pattern, oh my goodness, think what comes with that fluency. So we do a lot of that. I'm slightly obsessed by the 25 pattern. Again, I think that's a really good acid test like question. If you just have 3 questions, you want to kind of, you know, if you allowed 3 questions and then you have to like pitch how well your year 3s are getting on, that would be one of them. 25, 50. I just want them to say about 75, 100, because then that is all the things we talked about before. But look where else it goes. Look at this. If we are totally fluent in associating 4-ness with 25-ness, 4-partness with 25-ness in some form, look what comes with that. Well, that's just makes so much sense. And we had, I worked with a secondary teacher on the year 6 stuff in going to ready to progress criteria, and she said, honestly, no, she said, I'm not kidding. I mean, she was so lovely, and she was really respectful of primary, and she said so much good stuff about what she was seeing. But she said decimals gets rushed, which I totally agree. That was one of the reasons we put decimals in as the main place value, essential place value knowledge in year 5. She said, you must be rushing through decimals. She said, their fractions are great. You must be rushing through decimals. She said, honestly, half of my year 7s will tell me that a quarter is equivalent. They would write it as 0.4 as a decimal. So that's her perception. You're doing a great job in fractions in primary, but it doesn't feel like decimals have the same level of kind of prevalence, which I would agree with. I really don't think we do decimals justice. They get buried in a random fractions unit in the summer term. So yeah, a couple of things on counting there that may be a different aspect of fluency and counting that is all absolutely clear in the Ready to Progress. So all things you can focus on through the summer, the PowerPoints are there, just get counting through the school. So yeah, so finally, Jenny asked me to talk about fluency and addition facts. So Jenny, shall I aim to talk till about 5 still?
Yeah.
And then
that's great, Claire. Yes, please.
Obviously, I spent 9 minutes entertaining you with my technical incompetence at the start. Okay, so
there we go.
So fluency in number facts. So I'm going to talk a little bit about addition and subtraction and a little bit about multiplication and division. And yeah, both of them are things that have been interested in over the years. So yeah, number facts I'm totally fascinated by, and about 12 years ago when I started at this school in Bristol, where I've now been far too long, I had a girl called Natasha, and I have a bit of a memory of her in year 5 doing 6 add 5 by counting on her fingers, 6, 7, 8, 9, 10, 11. And I mean, obviously I knew children were doing that, but I was like, oh, come on, Natasha, you know 5 add 5 is 10. And she was like, yeah. So what's 6 add 5? And it was like total penny drop moment. She was like, is it 11? And I was like, how has she got to year 5 in our school and no one's pointed out to her that 6 add 5 is 1 more than 5 add 5? So anyway, that's where my interest started, really. We just started that time having a lot of conversations in year 5, just lots of, how could you do this? How could you think about, 8 add 6? How could you think about this? Blah, blah, blah. Then in year 3, I moved to year 3 the next year and thought, okay, come on, this is ridiculous that we're picking up children, perfectly competent children in year 5, counting on their fingers for everything. They've missed some really pretty important stuff mathematically if they've not figured out that 6 add 5 is 1 more than 5 add 5. So we mapped out all the facts and we were like, right, come on, let's do this. Let's get the children, let's get them all off their fingers and let's just get them all so they don't need to be doing all this ridiculous counting on stuff. So we mapped out the facts that we thought they needed to know, like the times table equivalents, which at that stage we'd never even seen that. We didn't even know what we're trying to get them fluent in at that stage. We were like, number bonds 2, 10, number bonds within 10, 2, 20, within 20 is 17, add 2, 1 is 8 and whatever. So we mapped them out and we were like, that is the logical fact of set of addition facts. They got up to 10 times 10. And logically, everything else additive is like an application of those and the inverse subtractions. And this is what we were doing. We were doing this very well. Number bonds to 10, we were doing it brilliantly. Unfortunately, we forgot to then teach children to recognize them in context. So they could tell us their number bonds to 10, but then when they saw 7 add 3 written down next to 8 add 5, it didn't occur to them it actually was a number bonds 10. And we were doing a fairly nice job of doubles, and we weren't teaching anything else. So there was no lesson where you could go to in our school where, okay, we're going, by the end of this lesson, they will know how to work out 3 add 4 without counting on their fingers. None of that we were doing. So we were doing lots of jumping on number lines, it's in the early learning goal to do that. It shouldn't be, but it is, or the old early learning goal that's coming to an end. So they're all doing this all the way through, jumping up number lines, and the classic put the bigger number in ahead and count on. So what we kind of concluded from this was actually we were doing a really exceptionally good job, because this strategy of putting the big number in their head and counting on, they were still quite happily using 4 years later. So we thought, wow, we're pretty good teachers. So do you know what? If we want them to do something different, let's teach them something different. And so we did. We started teaching them something different because we realised that actually what we've been teaching them, we didn't really want them to do. We kind of hoped they'd stop it, but we hadn't really planned how they would stop it. So we started teaching some different stuff. We did lots of conferencing. We didn't really know how to get them fluent. We knew we didn't really want them to count on their fingers because it seemed like they were missing quite important mathematical stuff if they were counting on their fingers for everything. And for some children, we could see it was a massive barrier. It was just cognitive overload, and trying to teach them column subtraction when they were counting on their fingers was, you could see that for some it just wasn't going to work. So we conferenced lots of children who were really fluent. This was the first couple of weeks of year 4, a child working above age-related, who was really fluent. And K is known fact, S is strategy. So what we discovered was that our fluent children were by kind of mid upper key stage 2, they knew a lot of facts off by heart. So he knew that 5 add 5 is 10, unsurprisingly. But for the facts across 10, like, I don't know, 8 add 5, he was using a strategy. So that was really actually interesting to us, because we thought, is it just about memorizing? No, and it wasn't just about memorizing at all. And then what we found for lower down, if we went to the year 2s who were getting pretty nice and fluent, tending to be the higher retainers, not always, but tending to be, we found they were using a lot of strategies down here. So they were using, you know, like 3 add 4 is a really good example. They were saying, well, 3 add 3 is 6 and 1 more is 7. So that's what the year 2s were doing. They were using strategies within 10. Apart from the kind of 2/3 of the class who were putting the beginner on their head and counting on. And this looks really, Jenny, can you see my mouse? No.
I can see.
Can you see my mouse wiggling around?
Yes, you can. Yes.
You can. Okay, great. Because otherwise it's going to be impossible to talk about it, so I'll just leave it out. It looks really heavy, but I will unpick it for you. So these guys, I think they're based in Birmingham, I think. Fascinating paper. They did something really similar. They basically, you know, went and gave children a load of number facts. How do you know 3 add 4? How do you know 6 add 8? How do you know blah, blah, blah? And they looked at 3 different types here. So you can see at the top where my cursor is. Within 10, one of these teens plus a single digit, within 20, and then these bridging ones here. And they went into schools and they said to teachers, can you give us some of what they call below average ability children? And I don't think we'd use that language now. And you want above average ability children. So they took them, and if we look at these, like this column here, which is the 8-year-olds. So these were the 8-year-olds here, this little rectangle, if you can see me drawing around it, is the 8-year-olds who were deemed to be below average ability. So what were they doing for all their facts? Well, at the bottom here, there's a bit of known facts. So there was a few facts they knew. And then in the middle, this kind of medium grey bit, lots of counting on. And then at the top, a lot of counting all as well. And then compare that with the higher retainers here. So they also had some known facts, more than the low retainers had known facts. This middle bit here, derived facts. So this is probably the biggest difference. So this was them using 3 add 3 as their knowledge that 3 add 3 is 6 to work out that 3 add 4 is 7. And this derived fact stuff here, look, completely absent, good as completely absent from the low attainers. No, but good as no independent derived fact strategy use. And they had a tiny bit of counting up at the top here, the high attainers. And over time, the derived fact strategy use decreased and it got replaced a bit more by known facts. So this was exactly what we saw in our school. Our children that were picking this up were using what they knew. They were using their knowledge of number structure, number relationships to work things out without their fingers. And, you know, this is one that if you guys have a think about, I mean, I think I must have probably asked 2,000 or 3,000 primary school staff over the last 10 years, this one. And if you have 20 people in a room, you can be pretty damn sure there will be one person who just knows that's 17. So I can pretty confidently say about 5% of primary school staff have memorized that that is 17 in the same way that we all just know 5 add 5 is 10. The vast majority of you will be using near doubles very quickly, very, very fluently, or you'll be using, you'll be 8 add 2 add 7, or you might add 10 and take 9. There's various things you can do, but the vast majority of you will quickly and fluently be applying a strategy to that. There'll only be about 5% of you that just know it's 17. So some things that we kind of decided, conclusions we came to. I mean, that was clear in our schools and it's clear in the research for sure. That was really important to us because we didn't know. We were like, do we just need to sit these children down and drill them? Is that what it is? And that is absolutely not what the research says, where addition and subtraction is concerned. I'll throw out something slightly more controversial about multiplication and division in a minute. And this is the depressing yet exciting bit. You know, and near doubles, I've talked about a couple of times. Near doubles is an example of a strategy that there are a good number of children who will never independently use a near double strategy. But oh my goodness, the vast majority of people pick that strategy up so quickly when they're taught it. And yeah, the national curriculum is a massive letdown here. I mean, this is year 1 here, fine, add and subtract 1 and 2 digit numbers to 20. But this bit here, oh, horrendous. Look, pupils should memorize facts like 9 add 7 equals 16. Well, most of us haven't memorized that 9 add 7 is 16, but there it is for the little 5-year-olds in year 1, just memorize 9 add 7 is 16. Not what happens, not what the research says. absolutely unrealistic. So from the beginning, we're completely unrealistic expectations, and we don't give the time and space and the explicit teaching of the strategies we need for children to be fluent in them. Yeah, I love this cartoon so much. Have you seen it, Rebecca, before? You're nodding. It's so good, isn't it? I just love it. And that, to me, literally sums up what we are doing with these poor little 5 and 6 year olds with addition and subtraction facts. We teach them to put the bigger number in their head and count on, and then we kind of just hope a miracle occur, and by some miracle they'll end up just knowing their facts. And that's just not what happens. But there actually, to us, is a miracle, and that miracle is like this derived fact strategy teaching. So yeah, it's so everything I've talked to up till now was kind of work I did with colleagues in school and things we got interested in school and just played around with. And then 3 or 4 years ago, I talked to my executive head about us trying to write something up in school in my SLE time, and we just couldn't really make it work. So a friend and I then started working in all of our spare time, evenings, weekends, late nights, early mornings, blah, blah, blah. And we thought, come on, we're just going to get this written up. So we've written up a kind of a full, I guess, scheme of work for number facts, get all children fluent in number facts. So we teach these strategies, and we are much more, we think, much more realistic than national curriculum. We say, look, let's just focus on year 10 within 1, and that's what's in the non-statutory guidance. There's no evidence that you can or should get classes of 5 and 6 year olds to become fluent in adding across 10. And then let's say, look, let's look at across 10 in year 2. Let's focus on that in year 2. That's in the non-statutory guidance. So here we go. So number facts and non-statutory guidance. Develop fluency within 10 in year 1. And look, year 2s, you're allowed to carry on practicing it. Secure fluency in year 2. So that's permission that we didn't have before, because poor year 2s, it's all about, you know, by year 2, it's like crack on with 2 digits, please. And the year 2 teachers are sitting thinking, but they don't even know what, you know, 3 and 6 is. But never mind, let's just tell them to put the bigger number in the head and count on. I've got my 2 digits to get through, because that's what national curriculum's told us to do. So we've been let down by that, I would say. So then year 2, ready to progress. Let's teach them to add and subtract across 10. But look, year 3 teachers, guess what? They won't know it by the time they arrive in year 3, not properly. So you need to continue doing that practice in year 3. And again, we've been set up to fail there. The national curriculum has, you know, no kind of sign that year 3 teachers should be spending time securing addition and subtraction across 10, and they absolutely should. In fact, every year 3 teacher I've spoken to this year, which is quite a lot, has said that their children need more work on within 10 as well. So, you know, this stuff is kind of hard to do in some ways, but it's really rich, because actually getting children fluent in these facts is all about relationships. So we've written a program that teaches fluency in these facts, and it does that through literally teaching 12 strategies. So those are the strategies that we literally just mapped out. We took all the grids and we said, right, okay, that's a good strategy. What does that cover? And then we had a few little gaps left. So we kind of had to come up with some other strategies like these, but they're great, they work. And this one here, if you have a look at that one, that's one you probably don't teach. We didn't teach. We found children were really bad at these subtractions. And actually, on one of our courses, I had a teacher from Kent on one of our courses, and she said, we were talking about all of this, and she said, I was in class the other day, and one of the children said to me, what's 4 minus 3? And she said, and my first thought was, how can you not know what 4 minus 3 is? And she said, and my second thought was, I know how you don't know, because I've never taught you. So this idea that teaching children that, you know, adjacent odd numbers, they've got a difference of, adjacent numbers have got a difference of 1. And then this grid kind of mapped them, I guess. So I think of this as a bit like your speed sounds chart. Like your speed sound chart in phonics tells you, right, these are the phonemes you're teaching, and these are all the graphemes you're going to be teaching that correspond to them. And this is really exactly the same idea. Okay, here's all the facts you need to teach, and here's the strategies which cover each. And it's slightly simplified because some facts are covered by more than one strategy, but that's the idea. And then we've broken it down into like a full scheme of work, and there's loads of materials on there if you're into. All of this stuff's free. Everything I'm talking about today is free. But if you want to get into it, there is a full scheme of work that we've written. If you log in, you can log in. There's quite a lot of stuff free on the website, and then if you log in, there's a lot more pedagogy around it. So if you do enter your details, you have to then choose to subscribe. You don't obviously enter any payment just to start accessing stuff. So like, here's an example of a strategy. You know, fine, it would be so quick to tell the children, you know, if we're adding 2, just go 6, 7, 8, or go 5, 6, 7. But we don't teach children at all to count on their fingers to add and subtract, which I'm not saying you should necessarily stop doing. I know that sounds quite radical, but we don't want them to count on their fingers, so we just never teach. We do a lot on number lines and understanding the linear number system, but we never ever tell a child to put the bigger number in their head and count on, and we never ever jump in ones along a number line with them. So adding 2, that's all about understanding the structure of odd and even numbers. Because if we really understand the structure of odd and even numbers, and we've got really strong visuals, that 2's wise visual, then, you know, we don't need to tell them to go 5, 6, 7. And then we have like loads of animations that essentially take children on that journey. These ones are all free. Not all of the strategies, all of the resources are free, if that makes sense, but these ones all are. So you can have a go at it if you want. So I just have a little look at how that leads children to factual fluency and adding and subtracting too.
Thank you. Quick question came in. These are all on Clare's Number Sense website. Look on claresnumbersense.com.
Yeah, that's all on it there. If you go to sign up, you can sign up, and then you get there's loads of pedagogy, like a blog there. We've got loads of our thinking on a blog that you don't even have to have a sign up for that. And look, we really try and keep it really current. We've done a load of development over the last week or so, because we've had just a flurry of interest and lots of schools saying that they want to focus on number facts when we go back, but are really mindful of teacher workflow. So we've just done a huge amount. That's all free as well. We've just done a huge amount of like mapping out really to the day what you could do over the rest of this academic year to get your children fluent in number facts. So that's all on there. So yeah, that's basically what we found about number facts. Essentially, the message in addition and subtraction facts is teach strategies. But then I'm going to give you a completely different message for multiplication and division facts. I mean, look, this is just us trying to work out this is us just saying we want our children to be fluent in addition and subtraction facts, and we want our children to be fluent in times tables and division facts. Trying to scrabble around, read what research we can find, and play around with systems that work. So our view now is that, well, 100% it's all about derived fact strategies and structure for addition and subtraction. And you don't get children to be fluent in addition and subtraction facts by drilling them, or it's not nearly as effective. Times tables. Now, I am not saying the only way to get children fluent in times tables is drilling them, but I am saying that is the way that we have found most successful in our school. So it could well be there's a school out there with a brilliant program which gets all of their children fluent in times table facts through looking at number relationships. I'm not saying that it's not possible to do that. It's just that we've never seen that, and we don't know how to do that in our school. So we found something that works for us. And I should say we teach all of the aspects of multiplicative relationships in our main maths lessons. And there's, I think, some really, really good stuff in the Ready to Progress guidance on that. In year 4 in particular, well, year 3 actually as well, but particularly in year 4, there's a really, really nice criterion all about multiplicative relationships. So all of that we do. So don't worry too much about our children. They are getting a conceptual understanding, but for times tables, we completely decouple that from the fluency. This is in the non-statutory guidance, this priority. This was one of my biggest like happiness things that we managed to get in the non-statutory guidance, this little bit of text up here. And for times tables, I'm just going to say this is brilliant, this little thing. If you send the slides around, Jenny, if you send them in PowerPoint, those are all hyperlinked.
Great.
It doesn't look it is, I'll make sure it is. And then we basically use, I'm not even going to go into it. There is a really, really comprehensive video on our website about how we teach times tables in a way that works. And like I said, I'm not saying you couldn't have a completely different program. With addition and subtraction facts, I'm pretty confident that that's the way to do it, the way I've described. I'm not saying this is the only way to do it, but it is a really effective way. And essentially it involves lots of little booklets. never letting them skip counts. They're all displayed on the classroom wall. If they don't know it, they copy it, and then we do a lot of chanting. And there's a whole pedagogy to it that I can't go through now, but if you've got 20 minutes and you are interested in having a push on times tables, if you go to our website, again, that's hyperlinked, but you can just type in Ashdown School and find it, the link there. So this is the final thing I'm going to say is this from this really, really good document here, which is a dense research summary about factual fluency. These were some of the things that said a specific performance criterion for introducing new facts. That essentially means make sure they know the facts they've just learned really, really well before you introduce new facts. So, you know, ours have these little booklets, and you'll see, I mean, I literally just grabbed, this was the first one walking past, but ours do these little booklets that are built up really progressively. They do 40 facts a day in 2 minutes. And, you know, most of them are getting 40 out of 40. The vast majority are getting 40 out of 40. And then a new times table is introduced. Intensive practice. Well, I'll let you read these. It just said, you know, regular 2 minutes a day or whatever it is. A record keeping system. We found that really important. We take the children's marks in every day. We just sit in the mark, but we just go through. They're just used to doing it now in the class. So we track really carefully. You're just aware when someone's plateauing, and then you just look for the little kind of intervention. You know, what's the fact they're working on? Ask them it 10 times through the day when you walk into assembly and so on. Our motivation system is completely intrinsic. We don't have any prizes, rewards. It's all very, very much kind of teacher-led. You know, praise and who's got 2 more than yesterday, who's got 5 more than yesterday. And what I will say, the one extra bit of context, because it's all in the video, how we teach them through this kind of rote memorization, like a sound pattern, really, like a song lyric, is when we introduced this, I was working across 2 schools, and we introduced it in both schools at the same time. And one, it just was wildly successful, and the other one, the kids all just kind of plateaued. And the lovely teacher in where they'd plateaued, he was like, I don't know. He said, it's not really working, Claire. We get the books out, we do them, and their scores have stopped going up. So I went into his classroom. I went into classroom of a teacher called Steve over in the school where it was going. And the difference was, I mean, he wasn't being awkward at all, the teacher in the school where it wasn't working as well. But the difference was actually the teacher motivation in the school, which was doing brilliantly. Steve was like, I am going to get these children knowing their times tables. All of them are going to know their times tables by the time they leave me. And he was just so attuned to, okay, you know, as Harry walked in, Harry, remember 8 6s, what's 8 6s? You know, he was just noticing those little children who were stuck, finding opportunities to practice, whereas the other teacher was like following to the letter what I'd said to do, but without any of the kind of ethos and kind of personal motivation around it, if that makes sense. So if you are interested in doing something, you watch the video and you think, oh, that sounds interesting. That kind of teacher understanding and like, okay, I'm really motivated, I get what we're doing here and how it works is quite important in success, I'd say. And the other thing it mentions is just get away from skip counting on the wall. And if that fails, which it has for our lovely, lovely, lovely little boy in year 5, who is the most delightful, sparky little thing. He is absolutely one of a kind, but he's a bright little button. We've done it with 360 children now, and this has been an abject failure for one of them, complete failure. But there's this completely bonkers book, which, I mean, the reviews on Amazon are hilarious. I mean, they're so unmathematical. The reviews on Amazon are either 5-star, like this book is a miracle, my child couldn't remember their times tables, or they're like 0-star, this book is totally bonkers. But this has completely captured the imagination of the 1 in 360 children for whom this doesn't work for. So I'm pretty confident that with this system and this bonkers book as a backup for those little quirky ones, you can have a good push on times tables, be fancy over the summer as well. So yeah, that's it.
Fantastic, Claire. Thank you so much. Can we go back to the panel?
Oh, Melinda, you've come across that book as well. I can't see all of Melinda's message, but she said that book worked for one of my struggling year 3s. Yeah, it's hilarious, isn't it? Oh, hang on here. This book transformed my timetable. My daughter thought it was nonsense. Yeah, I mean, it's honestly, it's worth just reading it's worth just going on Amazon just to read the reviews. They're so funny.
I bought it because I read the Amazon reviews, and I bought it, and then I looked at it and I was thinking, I don't get this. I don't get, but it's just for some children a visual clue will be all that they need to learn that fact. I really, really loved reading the decimal as a fraction, and that will take that away with me. So important. Thank you.
Emma?
Yeah, we've been amazed by the impact of that.
And what's your takeaway tonight?
There were so many things in there. I love the idea of generalisations as capturing a bit of maths, and that's the thing that you're going to take away with you in the future. I'm a massive fan of number lines that you've used throughout. I think really, really good for helping children see those relationships along the way. Yeah. I just really like that record keeping system as well. I think that's really key. As we said before, they don't come up again, those facts after year 2 throughout the curriculum. We're not really packing we need those generalisations as they go through Key Stage 1. So there were so many things. Thank you. It was brilliant.
Shall I share my takeaway? I just want to say that I've been jealous for quite a long time about the rigour of phonics and that systematic approach and that real kind of attention to detail and record keeping. And I think it's our turn. So I'm really looking forward to sort of mirroring that with those maths facts.
I think if ever there was a time to ring fence that part of your timetable and say we need this fluency session and what we need to fill it with, and this is why, and here's all this wealth of amazing resources right now, let's get it started. I don't think we will look back.
Can I just say one thing about the ready to progress stuff, is that especially as we come back, I honestly think it is so powerful. I mean, I learned so much working on that, but now I look back on it, I'm like, it's so cohesive and it's so simple. And I've seen quite a lot of documents that I found totally overwhelming that map that to the national curriculum, to White Rose. And somebody sent me one today and I felt a little bit sick looking at it. And I was like, I find that completely overwhelming. And I've been heavily involved in writing. I've unpicked the national curriculum, spent hours and hours doing it. So honestly, my advice would be, don't just try and do lots of complicated mapping. It would just be overwhelming to staff. I think the most accessible way in is just to take that document, take one strand in it. So you might take, say, the MPV4, well, you might take the MPV2 that goes all the way through looking at number lines, and just look at that. Forget about trying to map it to anything and pull it from this scheme of work and that unit can go there. Just look at that. Find one thing you're not going to teach. Like the year 5 teacher really doesn't care if you teach negative numbers or not in year 4. They really don't care. Find one thing in each year group you're going to deprioritize for a week and just do that for a week. So rather than trying to cross-reference it in all the time, does that make sense? That would be my biggest bit of advice, because then it just becomes another thing to think about, and it shouldn't be that. It should be absolutely liberating, that guidance. It should absolutely strip away, not add in.
Absolutely. Thank you, Claire. I think we've got so much positive feedback in the chat box tonight. Everyone's saying they've got full of ideas for their staff teams. You've reminded me of the old chestnut of the paperclip and the lovely strip of paper, Claire. I'll be digging those out in the morning as a slide of my number lines. That's wonderful.
This slider thing. This. Do you know, Jenny, this little double-sided number line, this is a decimal, so I just quickly got to say this. This was the very first thing I ever saw, my very first day in my PGCE, in my in-school experience. Like in my first week, you went into a primary school for one day. And that evening, they had a local authority maths consultant in who did a twilight. And I remember her showing these. So this was my very, very first ever bit of maths PD as a trainee teacher. They're so good.
Excellent. And I also, again, reminded me of the Shanghai teachers coming over and being obsessed about 25. So that's also been a really good reminder this evening. And I think what's also been really reassuring tonight is you talking from experience as a practitioner in a school and telling us, you know, warts and all, how it's been for you after lockdown. So we all feel a bit more, again, you know, reassured we're all in the same boat here. We're all trying to do the best by the children, and that's been just, again, such a breath of fresh air this evening, and really helping us find a way through and feel really positive about next week and what we can achieve in the time we've got. So I think that's been just such a brilliant session this evening, and it's lovely to know we can send the slides out as a PowerPoint so people can have all the animations to show their perhaps staff teams who haven't been able to join us this evening. That's really positive. And of course they can explore your numbersense.maths.com website to find all the freebies. There's just so much to go and explore and follow up, and of course your Ashley Down school website with your 20-minute video about timetables. I think again we'll all be making time to go and really review that and look at that again to inspire us further.
Jenny, Claire, we've had a request to stop screen share and to let Claire show her number line and slider so that we can have it so it's larger, so we can, because basically we can't see the numbers on it. I don't know whether it's going to work even like this. Maybe we could take a photo of it. Jenny, we can't hear you. You're on mute.
So this is year 4, 0 to 10,000. So you can just estimate. So you can do lots of things. You can either just estimate, and then the way you have to set them up is you just, I mean, I've got all these in a PowerPoint if you want to send those around as well. You just flip them like that. But then with year 4, what I'd really say is don't just give them the 0 to 10,000 with 1,000 intervals. Get underneath, get the 0 to 1,000 with 100 intervals and the 0 to 100 with 10 intervals, so that you're pulling out that 25, 205, 2005. No, because that will be the mistake they will make. They will tell you the midpoint of 2000, 3000 is 2005. And then this one I'd really recommend. This is exactly the same idea. This is year 5, and giving year 5s a decimals number line that has the tenths intervals and the midpoints. Just give them that and say to them, look at that for 10 minutes, and it will blow some of their little minds. But what they learn about the number system, just looking at that and going, why is that in the middle of that, rather than just giving ones with tenths on. Does that make sense? So for the decimals ones, put that in and just say, look, that is the number system, look at it, internalize, and tell me what looks weird about that to you, and let's unpick why it's not. So yeah, they're just laminated. You just have to make sure you do the 0s and 1s the right way, so you can do the flip. That's the really important bit, basically, because you can say, oh, where do you think 4/10 is? 4/10 is here, about here, and then you can flip it and see if you're right. That makes sense? They're so brilliant, and they go really well with that. And these as well. So, you know, measures, get out there. All of that linear number system stuff is about using measures. You know, this thing's absolutely brilliant, you know, for their estimating and their measuring. Okay, it's literally just one of those. Okay, let's estimate how long is this. We can do it either in tenths of a meter in year 5, or we can do it in, you know, centimeters in year 4. So estimate there, it's about 28. Let's roll around and check. So, you know, anything where you're moving between the estimating and the precision,
Excellent. Wonderful, Claire, thank you. Anything else in the chat box, please, panel?
There's loads of thank yous, people saying what a brilliant session it is, how well timed it's been. I think it energized everyone to take that step in forwards when the children return. Yeah, so just thank yous, and everyone wanting your resources, Claire, basically.
I was just the multiplication stuff that's on our school website. That's all hyperlinked in what I said. We've not done any stuff with that for number sense. So the number sense stuff we've written up is based on schoolwork, but then a lot of work out of school. That's the addition and subtraction. So yeah, I'll send through the PowerPoint with these in. They're a lovely tool.
Thank you.
That is absolutely brilliant. Well, thank you so much to everyone who stayed with us for the technical hitch at the beginning and right through to the end, well past our advertised finish time. It just shows again, Claire, how much everyone has valued this evening, and as I say, how it's absolutely hit all the right notes, and how much you have packed in to actually what has been a very short time. My goodness me, you have covered so much, and I love the way you linked again, you know, all the way from year 1 to year 6, you know, almost without taking a breath. It's just been so fantastic, that progression and continuity across the whole curriculum. So absolutely wonderful. And again, it's lovely to see, again, everyone obviously thinks just as we do. It's been, again, a breath of fresh air. Thank you so much.